Have you ever wondered how automated light sensors work? Or how headlights magically turn on when it's from day to night? These everyday marvels are made possible by the fascinating technology of light-dependent resistors. In today's technologically advanced world, where automation is becoming increasingly prevalent, understanding the inner workings of LDRs is essential for creating responsive and intelligent systems. Hi, hello, and welcome miners to this comprehensive tutorial on creating an LDR breadboard project. Throughout this video, I will guide you step by step on how to create an LDR breadboard project, empowering you to automate lighting systems and delve into the fascinating world of electrical components in mechanical engineering. Now, let's dive right in. LDRs, also known as photoresistors or photosensors, are remarkable devices that change their resistance based on the intensity of incident light. By using this property, we can design systems that automatically respond to light level changes. Imagine the convenience of having lights turn on or off depending on the surrounding ambient light. Sounds intriguing, right? Well, in this project, we will explore the practical implementation of LDRs using breadboard circuits, bringing automation and intelligence to your projects. Before we begin, let's gather the necessary components. You will need a breadboard, an LDR sensor, 1 kilo ohm resistor, a power supply, an LED light bulb, any color will do, and finally 1, 2, 3, 4, and 5 different color jumper cables. These components will serve as the building blocks of our project, so grab your supplies and let's embark on this electrifying journey together. Now let's explore the circuit diagram, which is the blueprint of our LDR breadboard project. The diagram illustrates the connection of the LDR and a resistor in a series configuration, forming a voltage divider circuit. This arrangement allows us to measure the changes in the resistance of the LDR, providing a measurable indication of the light level. By analyzing the output voltage across the resistor, we can then determine the intensity of the incident light. Now, let's bring our circuit to life on a breadboard. Follow along as I demonstrate the assembly process step by step. We want to begin by identifying our negative cable and connecting it to the ground port. Then we plug in our positive cable into the positive port. Next, we want to find our LED light bulb. I chose yellow, and identify the positive and negative sides. This can be done by seeing the shortest side, as that is the negative side, and then connect that to the breadboard. Now we want to take a different color cable and connect it into a series from the negative side of the light to the ground port. Now, take another color of jumper cable and connect it to the positive port of the LED light. Then connect the free side to another free port across the breadboard. Now, this is when the resistor comes into play, as we will connect it to the same line as the just connected positive wire, and then taking that free end and connecting it to the positive port. Now, we want to take another wire and insert it onto the port above the resistor, and then take that free end and connect it to another free port across the breadboard. Now it's time for the star of the show, the LDR. We want to connect the LDR to the port underneath the cable we just connected, and now finally inserting that free end into the ground port, thus completing the series circuit. Now we need some power, and in order to do that we must connect to the power supply. Let's take a closer look where we will be connecting our positive and negative ports into the 5V and ground ports. Now, let's plug in our power supply. For my instance, I'm using a power bank, in which I will connect the USB cable into. Great, so now let's bring our project to life by powering on our power bank. As you can see, the light turns on automatically. Now for the real test. By using a small keychain flashlight, I'm going to go ahead and move over the LDR with this light to see if the LED light turns off. Wonderful! Now we know that the LED light and the LDR sensor work, completing the final series circuit. As we near the end of this project, let's reflect on the lessons learned. In conclusion, through researching and creating the LDR breadboard project, I have gained a deeper understanding of automation sensor technologies and their applications. This hands-on experience has enhanced my technical knowledge and improved my research and laboratory skills, providing me with the valuable expertise that can be applied not only in my academic pursuits, but as well as in the real-world scenarios.